Hello and welcome to the Objective 7 video of the 2021 SANS Holiday Hack Challenge. I decided to do one last video before I am going to call it a day and then pick it up from here tomorrow morning, especially because the challenge after this one is a fairly long one and it also has a terminal challenge. This one though does not have a terminal challenge that would give you hints. If you solved the shellcode one, then Ruby is going to give you the hints. There are a couple of things with the shellcode challenge that I wanted to mention and I forgot to do in the previous videos. Let's take a look at it. Before checking out the objective for the printer exploitation one, once you solve the shellcode primer, there's the message here on the bottom of the page that says you can add the cheat after the URL before your unique identifier, and it will provide you with a solution. So if you're interested in that one and it's pretty easy to miss, then you can do it by adding that like so, and you will have an additional button here. You wish you knew it before we did the previous one, right? So you can click on this and it will load in the proposed one possible way of doing it. It's a little bit different than the one I did, but as you can see, it's very consistent with the results. But you might find some of the solutions, the official solutions, that is, might be a little bit different than what I had, but the end result is what matters. So this is just a side note before we get started on the printer exploitation one, and this is a fairly complex challenge. As you can see, the difficulty level is 4 Christmas trees out of 5. I think this is one of the harder challenges here, and when I solved the challenges initially, this was not the order. So I jumped through even the shellcode one and went with the Splunk, the noun hiring, or customer complaint analysis is a pretty nice and easy one. So when you do this, you probably are not going to go with this one, because I think this is probably the 4th or 3rd hardest one, depending on your background. We don't have here the challenge 8 listed. That's also a pretty tough one. 12 is a really tough one, and the FPGA programming one also has some twists in it that is, if you're not accustomed to do very log design, then probably going to keep you up during the nights when you try to solve it. But let's take a look at it. We're going to just do it sequentially, and once we solve this objective, another one should appear as well. There's another way to unlock the 8th challenge, and this is to solve the terminal challenge for that. So multiple ways to unlock it, but by default the Kerberos one, which includes a bunch of other Active Directory exploitation, is not available in the list by default. So let's do it sequentially and check out the printer exploitation one. This says investigate the stolen Kringle Castle printer, get shell access to read the contents of warspoolprinter.log. What is the name of the last file printed with .xlsx extension? Find Ruby Chrysler in Jack's office for help with this objective. Ruby is just standing next to the shellcode primer terminal, so we can immediately, after finishing up the shellcode primer, can start this challenge. I think this was the order that I did. So first I did the shellcode one, then the printer exploitation one, because I wanted to get the hints. And in this case, there's no terminal challenge that gives you the hints. It's just talking to Ruby after you completed the shellcode one. And Ruby says, oh man, was it this all about? Great work though. So first thing first, you should definitely take a look at the firmware. This is a very important hint to get started. With that in hand, you can pick apart, see what's there. You know that if you pan multiple flies of that type, the last one is processed. So this is a little bit a little bit cryptic, but it's yet another very, very important hint, and it doesn't even show up as a hint, so you either remember it or you have to go back eventually to Ruby, but it's a very, very important piece to solve this one. Have you heard of hash extension text? Again, without this you won't be able to solve it. So at this point, with some of the harder challenges, with the ones that have 4 or even 5 Christmas trees as a difficulty level, I think you won't be able to solve them if you haven't heard about those topics without getting the hints. All the hints are crucial for 4 and 5 Christmas tree challenges. Alright, so let's keep Ruby talking. If something isn't working, be sure to check the output. The error messages are very verbose. Everything else accomplished, you just might be able to get a shell. And so let me just get back here, because the error messages are very verbose. I just noticed this one as I am recording this video. This is also extremely important, and because the error messages are so verbose, when I hit an obstacle uploading my crafted exploit firmware, I immediately knew what was missing, and I could just fix it and upload the file again. But again, super important hint. And then get a shell access to that dusty old thing. Now, to solve the challenge, you need code execution. You don't really need to get a shell. It's absolutely feasible to get a shell. I didn't do it because to get the objective, you can just go for the file that is in the objective. So you your end goal is really just to know the content of the file. Either you pop a shell to do a reverse shell, or if you don't feel like it, like I didn't, then you need a code that will allow you to read up that file. And looking at the hints, I believe there is one that mentions this. So let's see. We have printer firmware, hex extension, and dropping files. So dropping files is the key that will enable you, without popping a shell, to read the file content, because it says files placed in this folder on the printer will be accessible under the /incoming folder. So if you're able to put something in there, you will be able to read it. Now, by default, there's nothing in there. You won't be able to see anything there unless you know the file name. So you need to append the file name to this URL, and that is a key piece again. Hash extension text. Well, without this, you definitely won't be able to finish up this challenge. And this is a reference to a tool and an article. Now, for me, this article was useful to understand how to use the tool itself, but not really on how the actual attack works. And let me just get a reference to hash extension, which is actually part of SANS classes, the advanced web application attack class content. Hopefully it's still there and I'm not misleading you, but there's a video online for sure from SANS uploaded on the offensive operations side, and this goes into details. I'm not sure why this is so blurry. So Adrien, the author of the 642, I think, the code for the advanced beta class. Yeah, there it is. So he will go through that part of the content. You can see that this is from day 4, and explain in great details how this given attack works. Now, I'm not going to go into details because it's 42 minutes, so we don't have time to watch this one, but that's a great reference to this. I will try to remember to put these either in a box or somewhere around this point, so let me just check So somewhere around 10 minutes, I will place a box that you can just click while you're watching this video, so you can stop it, watch that one if you want to, and also paste that link in the description of the video. And this is the tool that you can use, the hash extender tool. There's a GitHub page here. So we will use this tool for the attack, and it goes into the explanation. I think that the entire article is here on GitHub, which is pretty cool. So that's another key piece, and then the hint to start looking at the firmware. So this exploitation is really about taking the printer firmware and then pulling it apart and adding some additional code and then piece it back together while performing the hash extension attack, which is the basic idea is that if you use an incorrect algorithm, so you don't use HMAC, which is protected against this kind of cryptographic attack, then you can see that all these various hash algorithms are vulnerable. In a nutshell, just very high level, accepted level, the hash extension attack is an attack where you take a piece of information, use a secret key, and you take the secret, you take the information and then hash them together and provide the signature for this blob. And if something or someone wants to change the data, then by verifying this hash, you will be able to detect changes. The problem is the way how hashes work. You can put arbitrary long data into any of these hashing functions that you can see here on this blog post, and they will have to produce a fixed size. So inside of the algorithm, there are different steps, different transformations, and they keep repeating. So when you perform a hash, you can apply additional padding for this signature scheme and with the secret key and the data. And if you apply additional padding, this is all explained by the way here. So if you apply additional padding to it, you can see it starts with P, then you will be able to get to the hashing function kind of reverting back to one of the initial operations. So you can pick up hashing where you left off by applying sufficiently long padding, and then you can append your own data and create a new signature that is going to be still valid even though you don't know the secret key. Mind-blowing, isn't it? So that's the high level idea. We're just going to do the actual attack, but that's the high level theory behind it. Hopefully I explained it correctly. This was not entirely new to me. I had like vague memories from my university years when I took cryptography classes that this is a thing. They never actually performed the attack. So absolutely mind-blowing, fantastic challenge, great objective, and now I need to refresh here. So this was a ton of fun learning and piecing it together. And for this challenge, I'm going to use the Kali VM to get to the printer. So if you go, just get back here. So if you go back to the objectives, you will see the link in the objective to the printer. That's the printer interface. It looks shockingly similar to a printer's interface, and that might not be a coincidence. And you can see there's a status part, settings. You cannot access anything. It all requires passwords, so you can poke around here. But the only thing that you really have is the update firmware function, which is also here. And very helpfully, you can download the current firmware. I think this is the part that was just added to the challenge. So what we're going to do is just take the Kali Linux system. I also have the URL here, and we're going to use the hints to jump back here. So I'm going to close this one, and this is probably useful. So I'm going to grab the GitHub page, and I'm going to clone this repository first. That's going to be my first step here because we need that. So let's do a git clone and then paste this to clipboard. Let's take a look at my notes. I can also go ahead and download the firmware. This is something that we can again download from here. And I'm going to save it here in my user directory, and we can take a look at it even. So as you can see, we have a JSON file here that has a firmware field, a secret length, and there's also a signature here, and the algorithm. Now the secret length and the algorithm is something that you don't necessarily need, but it would have made this one probably a 5 Christmas tree type of challenge. You can sort of brute force this information and try all possible combinations, probably script it. But with these two pieces, the challenge becomes, I wouldn't say easier, but a little bit shorter to solve. But it's still going to be quite challenging, so don't worry about it. Once we have this, we can extract the firmware part. I'm going to use a few simple command line tools to do that. So we can do, for example, something like this. We can cat out the content and then pipe it into JQ. So this is something that I pieced together after looking at the JSON file. I realized, okay, I'm just gonna grab the part for the firmware and then pipe it into a file, just the base64 blob. And I'm going to keep around the base64 blob just in case. We can also decode the base64, and that will give us a zip file essentially. Just do this one without piping it into a zip. Instead, we can do something like I think head should be enough because we will be able to see that this one has what is it? PE? It should be a zip file magic bytes there. That's kind of strange. So after base64 decoding it, at the very end it does have decay. I'm wondering why is it not? Just give me a second. XXD. Just a few lines from there. Yeah, this one looks better. Okay, probably just putting it simply out on the terminal wasn't the best idea, but you can see the actual. So this is a zip file. I'm not lying. This is actually a zip file there. So the full command, which is clear this one up, is exporting it into a zip file, and then we can unzip it. And you already saw that the content of the zip file is a .bin file, which you can do a file command against it, and I think this will report it as an ELF binary. I did a few additional steps before going after the hash extension attack, so I did like bin walk, and I wonder if this will work. It had some extra characters at the end. You can also do strings on this and analyze that one up. This will not lead anywhere fruitful, so I'm not even going to do this last one here. But really you need to go with the hash extension attack, and once you have the repository for the hash extender rather cloned, you will still have to compile the binary. Now by default, the Kali Linux box does not have libSSL, so I had to issue this command and get the libSSL installed, but again, I'm not going to do that. We can essentially just do a make, and it's going to compile the tool for us, and now we have a test binary, and we actually have the binary for the hash extender. You can see all the various options. Now, I think one of the challenges in this objective is to figure out how to use this tool. And once you get that part done, you still need to figure out what to put exactly into the tool. To do that, I'm going to use a very, very simple payload. Let me just do, I'm going to call this one exploit.sh, actually not here. I'm going to go out and just do a very, very simple bash script. And my goal is to read the content of the printer.log file. So what I'm going to do here is have this bash shell copy this log file into that directory that was in the hint, hint that's dropping files. So I'm going to place it in this directory, and that way I will be able to access it under the slash incoming. I think that was the, let's check back. Yeah, slash incoming. So that's it. That's the idea. I'm going to save this one here, and what I need to do next is to get all the parameters for the hash extender. So this tool expects to get the original signature, the signature format, the secret length. You will need the data. You also need to tell the data format. So I'm going to do everything in hex, making sure that I have everything in hex format. And to do that, again, little bash foo is what I'm going to use. So up until this point, you saw this one. I'm just extracting the base64 block here, and then I'm going to take with XX the hex values, making sure that I don't have the line breaks, so it's all one continuous hex. I'm just trying to open this one up in mousepad just to show you how this looks like. So it's just the hex blob of the firmware, and this is one way how you can load in the data to the hash extender tool. I'm going to do the same thing for the exploit itself, for the file that I still need to prepare, because I need to make a zip file from this, which I forgot to do, but let me fix that one. So I need to put this one into a zip file, and this is what the troll Ruby says. I think it's not mentioned here, but if you go back and check again what Ruby says, you will see that, did you know that if you append multiple files of that type, the last one is going to be taken into account? So this is a very, very important hint that is not in the hints, but you need to use this. So I'm going to create an archive and clone this exploit.zip. Right, so now I have a zip file, and I'll take the hex version of that file again. Now I have both the original firmware and the exploit, the code that I want to run in the same format. You need to do this on the zip file, and this is also part of the challenge, part of the difficult part, where you just need to figure out this from the hints given by Ruby, or do a trial and error. But I checked some of the discussions on Discord about this challenge, and this seems to be the most common issue there. Now, for the last part, we need to take all this and feed it into the tool with the right parameters. So we have here also the hex for the exploit. This is the original JSON, and let's go to the tool. And I'm not going to do everything one by one, but I do have in my notes the actual command that I did. And for those who already solved the challenge, you know that there's oh, I'm not going to be able to see the whole thing. Okay, I'm going to open up another tab and just show you that way. This even fits there, so it's even better. So I'm going to use the hash extender, and in the meantime I can hit enter on this, I believe. All right. So I'm going to use the hash extender binary. I'm going to define that the data format is in hex. This is then the original firmware blob. The signature format is also going to be in hex, and this is the original signature from the JSON file. Then what else? The data that I'm appending is also in hex. This is the hex of the exploit zip file. And then we have from the original JSON the algorithm and the secret length. These are the two parameters here. And the output data format is also in hex. And I say -- table to get the new signature and the new data blob that already has the hash extension tag applied. And I'm going to output everything into out.txt in that folder. Just get here. So in out.txt, I have the new signature and the new blob here. Now I need to take this one and convert it into base64. I'm just thinking of making a copy of the firmware, and I'm going to rename this to exploit.json. This will fail, so I'm intentionally going in the route that I took to demonstrate all the steps, but I know that it's going to fail. So I'm not going to save this one. I just need this, and I need to, there are multiple ways to do the conversion. I did the lazy route, and I'm just going to do cyber chef. I need to convert it into an actual binary blob, and then I need to base64 encode it. So this one is multiple conversion back and forth with the different data types, but I do want to upload eventually a zip file, not just a hex blob, and you have the second zip file here. So that's all we're doing here. I'm going to copy this blob, and I need to go here and replace the firmware. Okay, accidentally deleted one of the double quotes. This looks better, and if you compare it with the original JSON file, you see that the first half of the blob is still the same, and I just appended data to it. Now, if you made a mistake, maybe during the tool creation, or for example, I forgot to do one crucial step here intentionally, and I can show this to you, and you go ahead, you're like, okay, awesome, I have the JSON file, and you try to upload this, you're going to get a very verbose error message. You have to verify the signature. That's because in this case, I forgot to replace the signature part here. I need to use the new signature. So this is a different hash, but because of this hashing method, which is insecure because it's vulnerable to this type of attack, I'm going to just start or continue where the hashing function left off with the original firmware. I'm going to append additional padding, and then the actual, I'm not even sure, maybe we can see the padding here. If I disable this, yeah, I'm not sure if we're able to see the padding here, or maybe I'm just not good enough, I'm not lead enough to see it, but we would take the original firmware, add some padding to it, and then continue with the data that we want to append. but then the output of the hash will be different. The state inside the hashing function will continue where we left off. So it's going to generate a valid hash, even though we don't have the secret key. And that's why you need to use something like HMAC. So I still need to replace the signature here. And then I can upload it. But even in that case, it will not work. But we're going to have a different, let's exploit JSON, a different error message. And now it says something went wrong. And it's complaining that the file name does not match firmware.bin. So it expects to have the file uploaded with this file name. So the only thing that we need to fix in this case is just to rename exploit.sh into firmware.bin. So let me just do that. I'm going to rename the original one something like this. So I'm not going to override this. And I think it's easier if I just open another tab because I need to repeat the whole process again. I'm going to rename exploit.sh into firmware.bin. Weird. I don't know how I ended up in home, but okay. And then I'm going to again create a zip file out of this one. So instead of the original exploit.zip, let me just probably name this maybe underscore, and then this is going to go into an archive. I'm going to call this one exploit.zip again, so that I can easily repeat the steps. Let's do underscore for this one as well. And the part where I transformed the firmware into hex is still perfectly good. So I just need a new exploit hex file. So this will change. This will remain the same. And then I need to issue another command. So in this case, I'm just going to paste it here again to show you. So the only thing that here really changes is this part here. Everything else fully the same. Rename the out file as well to underscore, and then get back to the tool and paste the, just gonna make sure that I have it right. Paste it from the clipboard, hit enter, and should be able to close this one. Get back here, reload it, and you could see maybe a little change at the very end of the blob that we're going to again append. And we have yet another signature here. The VM is struggling with all these large data blobs. Probably shouldn't do double click here. We'll get there. I just cannot double click on things anymore. Maybe I will close some of these. This one. I'm going to create a new one here in the meantime. So this was my previous attempt. Let's do another attempt here. Open it with mousepad. I'm going to need this part here, drop it into CyberChef, maybe clear it out, and then drop it into CyberChef. And I need to replace this. Looks good, so just some additional data, and I need to grab also the new signature. Let's try it again. So replace this, and I think we should be good to go with this one. Let me check my notes. Alright, let's give it a try. Hopefully I did everything correctly. I'm going to do rows and then again upload, but now the modified exploit. And it says successfully uploaded and validated, executing update package in the background. That's very, very promising. So looking back, you probably can remember what was the original attack doing. So I should have the printer under the incoming folder. And if everything went right, we do have the file. Isn't that amazing? I think it's totally mind-blowing. And this is the binding that we actually need. So I'm going to go back and well-deserved submission of the printer exploitation one. This is the file name. We're going to submit this, and we have a new narrative unlocked, and we also have now the crab roasting one, which I'm going to do after getting a good night's sleep because that's fairly complex. But let's reap what we saw. Where did we left off with the story? I think it should be this part here. So, is his best more pain than folly? Some have noticed subtle clues running around and raiding repos, stealing Santa's do's and don'ts and do's. So we continue with the little poem here. We have now another achievement under our belt, hash extension of L or firmware, getting it, L, and once again a new challenge unlocked, which is a 5 Christmas tree one and one of the hardest objectives here in the game. But that's for later. I had to do a little editing because again I managed to click somewhere where I shouldn't have, but you probably noticed it somewhere in the middle of the video, but I decided to stop it and then re-edit it. So this was one of the harder challenges, but again absolutely amazing getting through this. You probably saw that it's not easy, very complex, a lot of steps required, and you need to be very careful. But when you get that file appearing there, that's just absolutely amazing and very rewarding. So ton of fun. Definitely one of my favorite objectives here for these challenges. And the crab roasting one is also going to be pretty amazing. So make sure that you check the video. I think it's going to be on this side or this side. I don't know, this side probably. Click the link and you will be able to see the next one.